everyone, let's talk about anesthetics, how it works, which receptor it works on, and we're going to make it really nice, fast, and easy. So first step is, let's think about consciousness. So consciousness and movement. So consciousness movement is brought upon two things, which is neuronal excitability and excitatory neurotransmission. So if we block these two things, then we will lose consciousness and movement. And that's what we do when we give anesthesia. So first, let's think about, because for me, like, I don't know if it's easy for you guys to remember the difference between excitatory neurotransmission, which is when you, so this is the soma, this is the cell body, this is the axon, and this is the axon terminal, right? So this is transmission, so between one neuron to another. And neuronal excitability, so this is the neurotransmission. So this is, for me, I remember this as the domino effect. And then the next one is neuronal excitability. I remember this by thinking about all or nothing. So when you try to depolarize or excite with the action potential, the cell, we have a resting membrane potential and a threshold potential. And if the resting membrane potential does not reach the threshold potential, it just becomes a local, gives you a local effect. But if it reaches the threshold potential, then it becomes a full-blown excitatory effect on the cell, which would, and this is caused by influx of something positive, calcium, sodium, in the cell. So that's the all or nothing effect. The neurons will not be excitable unless you reach the threshold potential. So that's how I remember it. And anesthetic drugs work on presynaptic. Where is it? Here. It works here. So this one is pre, this is post-synaptic. So you can block it here and here. So next, let's think about what are the receptors in the body that we have that would give us these effects. So receptors would include GABA A, which is a inhibitory receptor. And then we also have sodium channels, which is excitatory. You know what, let's make it a different color so that it's easier for you to see later. And then let's HCN channels here, which is excitatory. And then potassium channels, background potassium channels, which is inhibitory here, both here. And then NMDA receptors, which is also an excitatory. So what are the, I don't know if it's easy for you to remember or it's also kind of confusing to you guys, but just to give you guys a story on how GABA A receptors work is GABA would be making when you open the GABA, it makes your chloride go inside the cell. And the cell, we know that it has to go past the threshold potential from the resting membrane potential, right? So it has to be more positive for it to reach the threshold potential. But if you're making chloride go in, you are making the cell more negative. So therefore, the RMP or the resting membrane potential will go down even further. And because of that, the distance between the threshold potential and the resting membrane potential will be bigger. And because of that, it is inhibitory. The sodium channel, like I said, this is the threshold potential, this is the resting membrane potential. The sodium, when you open the sodium channel, there's more sodium outside the cell versus inside. So when you open the gate, naturally, then sodium will rush in. So when it rushes in, then the potential inside the cell goes up. And if there's enough sodium to reach the threshold potential, it would excite the cell. So that's how the sodium works. Same thing. Oh, but the potassium though, it's tricky. You would think like, oh, positive, like why would it inhibit? The reason being is potassium is more prevalent inside the cell and there's less potassium outside. So when you open the potassium gate, potassium channels, potassium leaks out. And when it leaks out, the cell would then in turn become more negative. And because it's become more negative, resting membrane potential will go down, and therefore the distance between the threshold potential and the resting potential becomes bigger. So it's harder for you to depolarize your cell. So that's why potassium is inhibitory. Okay, that's that. So now let's move on to thinking about the drugs. Okay, what drugs work on each of these channels and receptors? So let's start with propofol. Etomidate. Propofol, etomidate, benzo, and barbiturates. So why I made this D instead of a T is because it reminds me that it works on the duration. increases the duration of GABA opening. So the GABA opening is more longer. So now there's more time for chloride to rush in the cell. Benzo, it does it by increasing the frequency of the channel opening. So like this. So more chances for the chloride to go in. So that's the difference between the benzo and the barbiturates. And then, so we know that all of these anesthetic agents work by stimulating the GABA A, and when you stimulate GABA A, it is an inhibitory receptor, so it inhibits neuronal excitability. The next one we can think of is volatile anesthetics like ISO, DES, EVO. And volatile anesthetic, it's not as clear as the mechanism of action is yet, and which receptors it actually works at, but there's a theory that is published in the books that it works on these 4 places. So it stimulates GABA A, stimulates potassium channels opening, inhibits sodium channel opening, and inhibits the HCN receptor opening. The next one we can think of is ketamine. Ketamine is works by inhibiting NMDA receptors and inhibits HCN. So ketamine, we give this when our baseline patient blood pressure is already low, or patient have hemodynamically instability. So you'll see more hemodynamic stability when you give ketamine. So if you give ketamine, it's you also of course have that feeling that, the patient will have that feeling of that he is not in his body, that kind of feeling. So we also like medicate for that, but apart from it is we mostly choose it for the hemodynamic stability that it gives. Versus propofol, if you give propofol, if your blood pressure is already low, then it will make your blood pressure even more lower. So you get ketamine instead. Okay, and then NMDA receptors, nitrous oxide and xenon. Xenon is theoretically have this effect as well, and it works by inhibiting NMDA receptor and stimulating potassium channels. Because potassium channels is inhibitory. So there you have it. I hope this makes it easier for you to understand the mechanism of actions. N2O, which is nitrous oxide, we try not to give it as much now because of the side effects. It causes nausea, vomiting, and many others. So, but we still see the use of it in giving birth for pregnant mothers, in OB/GYN, and also in the dentist's office. So like, there you go. I hope this helps you guys understand how anesthetic works, which channels and receptors it works in our body, and there you have it. Please like, subscribe, and share, comment down below, and I hope you guys have fun studying.